So 12.2 and 12.3 are all about surface area of prisms and cylinders. Make sure you get this in your notes, put it in your table of contents, and we got a bunch of writing to do. So get ready. So here we have a right triangular prism. I know it's a right triangular prism because the two bases, those two right triangles, they're the opposite congruent bases. The height of the prism, even though it doesn't look like it, the height of the prism is 7. Now, you would expect height to be up and down distance, but height of prisms is the distance between the two bases. So if that's the height, let's talk about drawing the net of this prism. So first, let's talk about drawing the prism freehand, not drawing the net, but just drawing the prism. Start with a right triangle. Draw another right triangle, kind of will be behind the first one, and then connect the vertices. And now the front right triangle, I'm going to kind of bold in the lines, the hidden lines, I'm going to dot those. And so you can see I've got this prism, this right triangular prism, and we had a set of dimensions. The triangles were 5 by 12, and the height of the prism was 7. So to draw the net, I'm going to use graph paper to draw the net just because it's going to make the right angles a little bit easier. First, I'm going to take a look at the bottom rectangle, that 12 by 17 rectangle. So that is sort of the foundation of this prism, of this net. Next, I've got that triangular top, the base. So we've got a 5 by 12 triangle. We've got two bases, so one above and one below. Then I've got that 5 by 7 rectangle kind of on the left side. And so that gets appended on to the lateral faces. And then, if you remember Pythagorean theorem, the third side of the base is going to be 13 units long. And so that kind of that slope side is going to be a 7 by 13 rectangle. And so here we have our net. Notice that the lateral faces all together make one big rectangle. And that's going to be important because the lateral area of a prism is the combined area of all the lateral faces. So you should note the lateral area, it has dimensions of 7 units tall, and the length is 30, which is the perimeter of the bases. So 5, 12, and 13 add up to 30. And so that big rectangle that's highlighted in yellow is a 30 by 7 rectangle. And so to find the lateral area of a prism, we'll take the perimeter of the base and multiply it by the height of the prism. Or in shorthand, we'll say L is equal to big P times H. So for this particular example, we have a lateral area of 210 square units. Now if we want the total surface area, we have to add in the two bases. So total surface area is the combined lateral area and bases, which is lateral area plus 2 times the area of one base, or L plus 2b. So in this case, we have 210 plus 2 times the area of one of the triangles. Remember, triangle is 1/2 base times height, so half times 5 times 12 is one of the triangles. And so we have a total surface area of 270 units squared. So now might be a good time to remind yourself those purple boxes are important formulas. We have lateral area is perimeter of the base times height of the prism, and total surface area is lateral area plus 2 area of bases. So make sure you get those down in your notes, the purple boxes there. Next, let's talk about cylinders. So drawing a cylinder, you want to start with an oval, also called an ellipse. I'll draw another ellipse kind of right below it. And if you connect the two ellipses, we've got ourselves a cylinder. Now, let's pretend the radius here is 3 units, the height is 5 units, and we want to find a net. Now, a net, we're going to start with the lateral area. The lateral area of a cylinder, it's kind of like the label on a can. If you remove the label of a can, you have this nice rectangle. And so the rectangle for the example given is going to be 5 units tall, and the length of that rectangle is going to equal the circumference of the circle. Here we've got 6 pi, which is about 18.85. So the lateral area, I'm going to extend the rectangle to about 18, almost to 19, and I'm going to call it 6 pi. And then the two circular bases, I'm going to add those in, up top and down below. And so there I have the net of the cylinder. To find the lateral area, again, the lateral area is the area of that highlighted rectangle, which is the height of the cylinder times the circumference of the base, or in abbreviated form, 2 pi RH. So that is the lateral area of a cylinder. So here we have 30 pi square units. And then the total surface area is the lateral area included with the bases. So here we have L plus 2B, or more succinctly, we've got 2 pi RH plus 2 pi R squared. So total surface area is lateral area plus 2 circles. And so total surface area here would add up to be 48 pi square units. So a couple of examples. Here we are asked to find the lateral area of this square prism. So since it's a square prism, I know that 5 by 5 square is the base. And we want to find lateral area. Remember, lateral area is perimeter of the base times height of the prism. So the perimeter of the base is the perimeter of a square with a side length of 5. The height, even though it doesn't look like the height is the distance between the two bases. Since the bases are squares, the height here is 12. So lateral area is 20 times 12, which is equal to 240 square units. Here's another example. We want to find the exact total surface area of this right triangular prism. So take a minute and sketch it down. So exact, that kind of indicates we might have square roots or pies. Well, probably not pies because we're not dealing with circles, but there might be some square roots in our answer. So total surface area is lateral area plus 2 bases. So lateral area is perimeter of the base times the height of the prism. And the bases are triangles, so it's 1/2 base times height. A thing to note here is the two heights are different. For lateral area, the height is the height of the prism. In other words, the distance between the two triangles. For the triangles, the area says 1/2 base times height. That height is the height of the two triangles. So first, let's talk perimeter of the bases. We know the bases are right triangles, special right triangles. With a short leg of 4, the 30, 60, 90 has 4, 8, and 4 root 3 as side lengths. So the perimeter there is 12 plus 4 root 3, times the height, which is 7. And then we want to add two triangular bases. So 2 times 4 root 3. Now distribute 7. We get 84 plus 28 root 3 plus 16 root 3. And that gives us a final answer of 84 plus 44 root 3 square units. That would be the exact total surface area for this prism. And then to close, we've got a word problem. It says a cylinder has a total surface area of 528 pi square feet and a height of 10 feet. What is the length of its radius? So we know, since we're dealing with the total surface area of a cylinder, this is the formula we're working with. And we know total surface area and we know height. So let's substitute in those values. We know we want to solve for r. So first, look at the right side of this equation. We have 2 pi r times 10 plus 2 pi r squared. The common factor there is 2 pi, and so I'll factor that out. Then divide by 2 pi on both sides of the equation. You get 264 equals 10r plus r squared. Subtract 264 from both sides, and we get 0 is equal to r squared plus 10r minus 264. And so now we have a factoring problem. We're looking for factors of negative 264 that add up to 10. Well, positive 22 and negative 12 work. And so there are our factors. The first factor, r plus 22, if that equals 0, then r equals negative 22, or r equals 12. Now, algebraically, both of those answers are correct. But in terms of geometry, r equals negative 22, that makes no sense. And so we have a radius of 12 feet. And there's our final answer.